So we'll be recording the webinar and posting it to ISAP's website on our resource page. So I just want to take a minute to introduce ISAP and our work. So the Illinois Sustainable Ag Partnership is a group of 15 organizations who are working together to advance conservation agriculture in Illinois and improve soil health and water quality. The group was formed in response to the Illinois Nutrient Loss Reduction Strategy, which was created in 2015. And ISAP works to provide coordinated efforts from the agriculture sector to achieve the nutrient loss reduction goals. And we've adopted a sort of train the trainer model because we know that if Illinois has a strong network of farm advisors who have a solid understanding of conservation principles, we can better reach and support farmers and help them in achieving their own conservation goals. So this webinar is being hosted as prep work for ISAP's Advanced Soil Health Training, which is a 12-month intensive training program focused on soil health principles that ISAP hosts every year. And we are excited to be joined by Brittany Loewen, hopefully soon. She is the Nutrient Maximizer Sales Leader with Corteva. And her presentation on the nitrogen cycle, the role of N inhibitors, and how to minimize nitrogen loss will be really valuable information for us before the second training session next week. So once Brittany joins and starts the presentation, feel free to add any questions in the chat throughout the presentation, and we'll have time for questions and discussion at the end.
Let me jump in here, guys. I apologize for that, but I am really excited to be here today and very excited to chat with you guys about the role of nitrogen and some of the factors that really affect nitrogen. And as we all know, with nitrogen prices being where they are, it is such a critical input for our crops and something that we really need to make sure that we're taking care of. So really excited about the discussion that we'll have today. I do have time at the end for plenty of questions. So as we get there, certainly feel free to ask me those questions or type them in the chat. I'm happy to talk through those. So we'll go ahead and jump in here. So the role of nitrogen in crops, an extremely critical element as we think about the building blocks of a crop. In particular, I think about corn. Being in the Midwest, that's certainly where I tend to go in my mind, but an incredibly critical role in any crop. As we think about nitrogen being essential in the structure of amino acids, protein, many enzymes, and metabolic reactions in the plant, and it is a critical component in the production of chlorophyll. So how that plant grows is directly related to that nitrogen availability in the crop. And so really critical as we think about growing the best crop possible to think about that nitrogen being a key input source. Important to understand that plants absorb both ammonium nitrogen as well as nitrate nitrogen. Ammonium being that positively charged NH4 and nitrate nitrogen being that negatively charged NO3. It's also important to note that NH4, ammonium nitrogen, is especially crucial for that early crop growth in many species. So I've heard it said that ammonium nitrogen is almost like a carbohydrate, like a sugar. Like we think about like a quick source of energy for humans, it is a quick source of energy for plants as well. It's also interesting that as hybrid development has come along, some hybrids actually prefer ammonium nitrogen, and you can see an even greater yield response, but depending on how much ammonium nitrogen is there available for that plant. But a combination of both ammonium and nitrate nitrogen does improve that overall plant growth and health. And again, that plant can take up both forms of the ammonium and nitrate nitrogen. It is interesting to note that once in the plant, that negatively charged nitrate nitrogen is ultimately converted back to the positively charged NH4, which is an energy consuming process for that plant. So the plant does go through that process of converting it back into that ammonium nitrogen. But again, the plant can take up both sources of nitrogen. And again, nitrogen is essential for that plant growth and yield. So really critical in the entire production process. One other thing to note about these two forms of nitrogen, ammonium nitrogen is positively charged. I think I mentioned that. Really important to think about with that negatively charged soil. So as we think about that cation exchange capacity and the ability for that soil to bind to those ions, with ammonium nitrogen being positively charged, it really easily binds to that negatively charged soil. Nitrate nitrogen is negatively charged, and so it is repelled by that negatively charged soil, which means that it can move through the soil in all directions, making it susceptible to loss. That is in comparison to that positively charged ammonium nitrogen being relatively immobile in the soil because it is bound to that soil. It is important to note that when I say bound to that soil, it doesn't mean it's tied up. It is still very much readily accessible by the plant. It doesn't stay in the soil where the plant cannot access it and cannot take it up for nutrients. But just a difference there between the charges of ammonium nitrogen and the nitrate nitrogen. Let's talk about the nitrogen cycle a little bit. So nitrification is the biological process in which nitrogen in that ammonium form, that stable, positively charged ammonium form, is converted into that unstable nitrate form. So the moment that nitrogen is applied to the soil, this process starts happening, assuming that the temperature is there for that bacteria process to start happening. But that process is going on below the soil profile. So as you can see in the infographic there, that positively charged ammonium nitrogen, that NH4+, there's a bacteria that converts it first into nitrite nitrogen, which is that NO2 that you see right there in the center of the infographic. And then from there, it gets converted into the nitrate. So this is a process, again, it happens in the soil. It starts from the moment that nitrogen is applied. It happens via bacteria that are in the soil that are breaking down that ammonium nitrogen into that nitrate nitrogen. And the presence of moisture and temperature affect how fast this process happens. But as we just talked about, that unstable, negatively charged nitrate nitrogen is in turn subject to loss. And two ways that that nitrate nitrogen can be lost is through leaching and denitrification. Denitrification is the loss of nitrogen that happens in the atmospheric form of greenhouse gas. And so this happens when soils are saturated, which cause that anaerobic condition, meaning that they lose that nitrogen element and it is lost to greenhouse gas emissions. The other form of loss is through leaching. This is through the groundwater. And again, it's because of that negatively charged nitrate nitrogen that it can then move in the plant root zone. And unfortunately, if you get too much rain, it can move out of that plant root zone. So I mentioned that the process and how fast this happens is a direct result of temperature and moisture. And as you can see here, temperature is a big factor in this. And it makes sense, right? When you think about bacteria, bacteria love warm, moist environments. And so as you can see, with the temperature raising to 75 degrees Fahrenheit, you can see this process happening of ammonium nitrogen being converted to nitrate nitrogen in as little as 2 weeks. So if you think about that in a real world environment, if we're applying our nitrogen, say a pre-plant application, but we've got some nice warm spring temperature days, if there's enough moisture and that bacteria is really moving, we can have that ammonium nitrogen be converted into that nitrate nitrogen in just a couple of weeks, making it incredibly susceptible to loss, and still a very long season in front of us where that corn plant needs that nitrogen, and yet it is in that form that is highly susceptible to loss. So again, really important to think about that the warmer the environment is, the faster this process happens. I've got it here in a different format, but you can see on the flip side of that, when we have soil temperature low, which is what we get over the winter, that bacteria is essentially not working on that ammonium nitrogen. And so that conversion process is much slower, essentially non-existent because of the temperature. The bacteria are essentially immobile. They're really not working on that nitrogen and not converting it. But As those temperatures warm up in the spring, again, that's where we really start to see this conversion process happening quickly. Some other factors that affect nitrification, or this process of how that ammonium nitrogen breaks down into nitrate nitrogen. A couple other factors is the supply of ammonium ions. So the form, from applying the ammonium nitrogen, as well as from that decomposing organic matter. So both the nitrogen application, as well as what's already going on. If you got a no-till situation, obviously you're going to have a lot more nitrogen there already within the soil profile. In addition to that, it's the population of nitrifying bacteria. We do see that this bacteria is present in every soil, but there is variances in the population depending on that moisture and temperature. And so again, the warmer and the more moist environments are going to create a faster process of this happening. Soil temperature, we've talked about this. Moisture, again, that nitrification does slow down in the dry soils. And as we get those spring rains, more moisture in the soil, that's going to mean more bacteria activity, faster breakdown from ammonium to nitrate. Soil pH and soil aeration also affect this, but the biggest factors really are that soil temperature and moisture. Those are really the two big drivers that are going to affect this nitrification process. And then the nitrogen losses, as we talked about, kind of what those two forms of loss are. Again, denitrification being that anaerobic decomposition of nitrate that happens where we lose that nitrate nitrogen through the atmospheric greenhouse gas emissions. But it's interesting to note that you can have denitrification even if your soil is not waterlogged. So we've got a great photo here of waterlogged soils, some ponded soils. We get this happening a lot in the spring. I know there's very often times where I'll be driving down the road and you see exactly what's in this picture. But it doesn't take that level of saturation in order for us to lose nitrogen through denitrification. We can lose 10% in a matter of 3 days of saturated soils. And then we can lose an additional 10% for each additional day that those soils stay saturated. So an example would be if you got 5 days of wet soils, which not uncommon for us to see that in the spring, you can lose 30% of that nitrogen that's in that nitrate form. So some pretty concerning statistics there. The other piece of it is that leaching. And so leaching, again, is when that nitrate nitrogen moves through the soil profile because of water that is moving through the soil profile. And so it's interesting to note that an inch of rainfall can actually move nitrates as much as 12 inches or a foot down when you have a coarse textured soil. So when you think about an inch of rainfall moving that nitrogen a foot, it doesn't take very long before that nitrogen is out of reach for our plants, right? When you think about where the roots are and when we have those spring rains, those roots are still quite immature, not reaching down very far. And so if you've got a lot of rain and a lot of leaching happening, that nitrogen can very quickly get out of that soil profile where the roots are. So some interesting facts here. The other piece that I would note is that denitrification and leaching are 70% of where we see nitrogen loss. There is an additional 30% that can be lost above ground. This is when nitrogen is applied and laid on the soil, whether through a reapplication or a UAN application where it's laid out on the soil. And if you have hot, dry conditions, so the exact opposite of what we're talking about here, hot, dry conditions, often we see this later in the season, but those hot, dry conditions can lead to volatilization of that nitrogen as well. So I think it's important that we talk about the 4R. I think everyone on this call is probably familiar with 4R and just the importance of that stewardship that goes into making sure we are being mindful and intentional about utilizing the right source, the right rate, the right time, and the right place. And we at Corteva are extremely supportive and very much endorse utilizing the 4R principles. We certainly believe that they're critical. And then we like to throw in that we think that there's a 5th R, which is the right stabilizer, because the good news is while these forms of loss happen and are a very real threat to farmers across the country, we have a solution that can help slow down this process and minimize that loss that farmers are susceptible to experiencing with their nitrogen. So the last thing that I wanted to say here, and I mentioned this already, but nitrogen is at risk from the moment that it's applied. Again, that 30% of the nitrogen loss happens above ground through volatilization, and 70% can be lost below ground due to the leaching and denitrification. And so it's really important from a farmer's perspective that you're thinking about how do you protect that nitrogen, not only from an environmental standpoint, from a crop maximization standpoint, but also from a financial standpoint. When we look at the price of fertilizer, really critical that we're getting the most out of that application and that we're effectively utilizing that application of nitrogen that we're putting on. And so our products, Inserve and Instinct, next-gen nitrogen stabilizers, we affect that nitrification process. So I talked about the process of ammonium, positively charged nitrogen, breaking down into that negatively charged nitrate nitrogen. And Instinct and Inserve come in and they actually work on that Nitrosomonas bacteria, which is the bacteria that breaks down that nitrogen. And we essentially starve that bacteria. So we work on their feeding process and we starve that bacteria to a state where they are lethargic, they're not moving, they're essentially paralyzed. At the rates that we apply our products, we do not kill the bacteria. Also important to note that we only work on Nitrosomonas bacteria. We don't have any effect on other bacteria. So we don't, for example, affect that Nitrobacter bacteria, which is what breaks down the nitrite into the nitrate. We also don't have any effect on the good bacteria or any other bacteria in the soil. It is entirely limited to that Nitrosomonas bacteria. And again, we slow down those bacteria. We put them into a form of stasis or paralysis, essentially slowing down this nitrification process. So what you get is less bacteria working on that ammonium nitrogen, meaning that you're slowing that conversion time from happening. And what you get, excuse me, what you get is you actually end up extending your nitrogen availability for up to 8 weeks with spring application. So again, I mentioned that it's very critical, the temperature and the moisture level. And so these are approximations based off 40 plus years of research, thousands of trials. But we have seen pretty consistently with a spring application, you get about 8 weeks of extended availability of that ammonium nitrogen in your soil profile. And you can see this is represented by these blue circles. And so the unstabilized here, you have in the NH4 form when it is applied. Because of that nitrification process happening, you end up with a number of negatively charged nitrate nitrogen ions. And because of the leaching and the denitrification, you end up seeing loss as a result of that. And so you're left with quite a bit still of that nitrate nitrogen and then just a little bit of that ammonium nitrate, of the ammonium nitrogen left. Compared to, on the right side of your screen, you'll see that NH4 is happening during the nitrogen application. Because of that breakdown happening, you do still see a little bit of that nitrate nitrogen, but you'll notice that with a stabilized application, the majority of your nitrogen is still in that positively charged ammonium form, meaning you're going to be losing a lot less of your nitrogen to denitrification and leaching. And so your end result is a lot more available nitrogen at the end of those 8 weeks. And you do end up having more ammonium nitrogen. That process will still continue to take place. Again, as the weather and the moisture happens, that bacteria will recolonize and they will continue to grow. And so that nitrification process does happen still. It's just that our products slow that process down. We do have products that work for any nitrogen source. We've got Inserve for anhydrous ammonia, Instinct for UAN, urea, and liquid manure. So no matter what form a farmer chooses to apply his nitrogen in, we have an option to help slow down that nitrification process and help them get the most out of that nitrogen investment. Important to talk about, we talked about nitrogen being such an important role in the growth of that crop, and you actually see it as we measure the benefits of Instinct and Inserve. We see that coming in terms of benefits to the crop, being that the nitrogen remains available. And so we certainly see it through increased yield potential, but we also see it in improved crop quality and plant health. So we see better standability, girthier stalks, better ear count, a lot of these benefits that show up as a direct result of that nitrogen being available for the crop, because that nitrogen is involved in so many of those processes for the plant. When we slow that nitrification process down and have more available nitrogen, it means better results in a variety of different ways for that crop. Certainly not limited to, but definitely including that yield potential that's there. The other piece that I think is important to talk about is the environmental aspect. So this is one that I recognize is not a primary driver for farmers right now making their decision, but I think it's one that is continuing to grow and will be very critical as we look ahead to the future. When I think about what we want to do as an industry, right, the entire ag industry has an opportunity to really make a difference. And I think that this is one way that we can do it. And this is directly a result of these products of nitrogen stabilizers, Instinct and Inserve being utilized. It means that less nitrate nitrogen ends up in the groundwater, ends up in greenhouse gas emissions. And so, as I mentioned, more than 40 years our products have been on the market, thousands of trials, third-party research. We demonstrate that availability of nitrogen for 6 to 8 weeks longer. But what this means from an environmental standpoint is a reduction of nitrogen leaching of 16%, a reduction of greenhouse gas emissions of 51%, and greater soil retention of that nitrogen by 28%. So really some very tangible, very impactful benefits that you see as a direct result of these products being utilized and of that nitrogen being available for longer. What does this mean in real world example? So that 51% reduction of greenhouse gas emissions is the equivalent of 3 million tons of CO2. And that 3 million tons of CO2 would be comparable to 337 million gallons of gasoline, as well as 646,000 gasoline-powered vehicles driven in a year. And this is, again, based on 1 year of utilizing these products right now in agriculture today. This is what we as an industry are helping to contribute to the earth, is that reduction of 3 million tons of CO2. And so as we increase the utilization of stabilizers, these benefits only increase as well. One other thing I'll note here from an environmental standpoint is that Corteva was awarded the Green Chemistry Award because of that Optinite technology in 2016. And really, at the end of the day, it means that we did what we said we were going to do from an environmental standpoint, and all those benefits that I just talked about is what earned us this award. In addition to that, we also were able to add about 50 million bushels of corn, equating to more than $205 million in additional production revenue for U.S. corn growers. And again, that's in 1 year that we're able to contribute that much benefit to both the yield potential as well as to our farmers at the end of the day. A couple other things that I'll note, again, proven for over 40 years. Environmental benefits are great, but we also do show a demonstrated and consistent return on investment from a yield standpoint. As you can see here, around a 7 bushel advantage with Inserve, around a 6 bushel advantage with Instinct. These are over hundreds of trials, so 757 observations for Instinct and 218 for Inserve. You may be wondering why there's so many more for Instinct. This was right around the time that Instinct was being launched, so we had a ton of trial data happening. But even with that, you can see very consistent results, somewhere between 6 to 7 bushel advantage with these products that you're getting over hundreds of trial results over many, many years. So we're really proud of these very consistent results that you'll see from our stabilizers. This is a visual representation. You may not always see a visual, but again, this goes back to that idea that nitrogen is such a critical building block for a plant that you can see a yield response when you do manage your nitrogen appropriately. So this is a situation in which we've got 160 units plus Inserve, and then 160 pounds, 160 pounds, and then nitrogen ammonia anhydrous ammonia by itself, again applied with Inserve by itself, and then Inserve. So you can see the striping effect that you're getting by having that Inserve available and making sure that that nitrogen is there when the plant needs it. Another visual, again, you don't always see this, but it is pretty incredible when it does happen. Clearly, nitrogen was the limiting factor here. I know we talk a lot about what's your limiting factor in terms of crop development. And so if nitrogen is your limiting factor, this is absolutely where you're going to see some response, not only from a massive yield response like this, a 16.5 bushel yield response, but also you can see the visual difference between having that stabilizer versus not having it. So again, that corn was certainly needing additional nitrogen, and without having that additional nitrogen availability, it certainly suffered, as you can see here on the right side of the screen. Another piece I'll look at here is that ammonium and nitrate nitrogen. So this is really a measurement where we can look at exactly that. Basically, we can demonstrate that our products are doing exactly what we say that they're going to do. This is through NWatch, through the program there in Illinois. And so as you can see on that first one here, coming out of Bureau County, and when you look at with Inserve, you've got 59% of your nitrogen as nitrate nitrogen, and 41% of your nitrogen as ammonium nitrogen. And this is, let's see, about a month and a half after application, so about 6 weeks. So we're looking at right at 6 weeks, which we say that Inserve provides you 6 to 8 weeks of extended availability. And you can see there that that process is still happening, right? We're still getting nitrate nitrogen. It's just that we've slowed it down compared to the unstabilized, because as you see in the unstabilized, 87% of your nitrogen is in that nitrate form. So 87% is in that negatively charged nitrate form, which means we're at May 19th. Oftentimes we're still getting those rainfall events happening in May, in June. And so all that nitrogen, that 87% is still susceptible to loss, versus only 13% that's available in the ammonium form that's positively charged. It's going to be more stable in that soil profile. Same picture in the other counties that we're looking at, 54% with Inserve versus 86% with unstabilized, 47% versus 90%. So I'd certainly want to be in a situation where I've got about half of my nitrogen in ammonium form and half in nitrate form, versus a situation where I've got almost all my nitrogen is in that negatively charged nitrate form, and I'm looking out the window watching it rain and wondering, how much nitrogen do I have left, right? That's a concern that we hear a lot from farmers after a rainfall event is, how much nitrogen do I have? The good news is that with a stabilizer like Instinct or Inserve, you know that you're doing everything possible to extend that availability and make sure that you're minimizing your losses. So just to kind of close out here, and then I'm happy to answer questions. We believe that it's really important that when you're evaluating a nitrogen stabilizer, that you're really looking for the best, so that you can have confidence in what you're putting out there, and that you can have confidence that you are protecting that nitrogen investment, not only for your financial story, but also for the health of that crop, and for the importance of making sure that we're giving that crop the best potential it has to reach its full optimized yield. And so really we look at delivering proven, reliable return. I mentioned thousands of trials, the environmental benefits that we talked about. We consistently deliver that 6 to 8 weeks of longer protection, so that nitrogen is there when the corn needs it, ultimately reducing that leaching and denitrification that happens, and then from a return standpoint, consistently delivering about a 7 bushel return on investment, about a 7 bushel return, which depending on corn prices, obviously is going to change your financial picture there, but really a powerful story when you look at the ROI for a farmer. This is kind of reiterating the point there, but I would just end with the fact that we are very, very confident that when you put a nitrogen stabilizer such as Instinct or Inserve out there, that you're doing the very best that you can for your crop to maximize that nitrogen investment. And then the only other piece that I would touch on, just because I think it's interesting and we do get a lot of questions about it, is the biological space. So Corteva does have a biological when it comes to this macronutrient space. It's called Nutrition N. And this is a product that actually pulls nitrogen from the atmosphere and converts it into ammonium so that that plant can utilize that nitrogen. Think of it as a supplemental source of nitrogen, a late season kind of bump of nitrogen, which is a really cool tool to have in your toolbox when you think about those spring rains and you are concerned of, oh man, did I lose my nitrogen? If you are concerned that you might need some of that late season nitrogen, a tool like a biological providing that supplemental extra kick of nitrogen is a really interesting one to have in your toolbox. So this is a brand new product for us. We are only in our second year of being commercial. And so we're seeing a lot of really positive yield responses, but it's something that I think we've all got our eye on is this biological space and how do these biological products help us with making sure that we have enough nitrogen for our crops at the end of the year. So that is what I have in terms of slides. I am happy to answer questions. I think I did see one in the chat here. So yep, hang on just a second. I'm going to take a drink. Okay, so we have a question here in the chat. Can you elaborate on the Optinite technology and how it works? So I think we went through it, but Optinite technology is a way of saying the technology that is in both Inserve and Instinct. Excuse me. So same Optinite technology, same active ingredient, Nitropyron, is what's being included here in both Inserve and Instinct. And when we say Optinite technology, it is the active ingredient of Nitropyron, but it is also how we get that active ingredient into formulation. A fun fact about Nitropyron is that it has been on the market for almost 50 years now. It has been off patent for decades, and yet there are no other manufacturers in this space because it is a very challenging molecule to work with. It is incredibly effective, as you can see from the results that we get, but compared to other active ingredients on the market, it is exponentially more effective. However, it is challenging to work with, and that's why you don't see any other Nitropyron products out there. It's because it's just really difficult. And so that's where that Optinite technology comes from. It's both the active ingredient as well as how we get it into formulation. But again, as you look at how these products work, this is probably the best slide to show you how that technology works, how this active ingredient works. Again, is where it comes in this nitrification process. So where that bacteria, two different bacteria that are in the soil that complete the nitrification process, Nitrosomonas bacteria and Nitrobacter bacteria. And so our products work on this step in which ammonium nitrogen is being broken down by that bacteria into nitrite nitrogen. And so we put that bacteria, the Nitrosomonas bacteria, we put it into a form of stasis. Again, we basically starve it. And so it's much slower. It doesn't work as fast. It's essentially paralyzed. And so it slows down that process of going from that ammonium nitrogen into the nitrate nitrogen. And so, but again, it's bacteria, right? It's a living organism. So it does recolonize. It does continue to repopulate. And so that's where you see this isn't a season-long control type thing. You're buying yourself about 6 to 8 weeks more time. The good news is that 6 to 8 weeks more time marries up really nicely with the corn uptake curve. If you guys have walked through that, Helen, or excuse me, the nitrogen uptake curve. So a corn plant starts to rapidly uptake nitrogen as it gets further in its production cycle. And so you want to try to buy yourself time so that you've got the most amount of nitrogen available when your corn plant starts to rapidly uptake nitrogen. And that happens as you get into like the V8 timeframe is really when you start to see a rapid uptake of that nitrogen. Okay, next question. You mentioned that N-stabilizer products essentially paralyze the Nitrosomonas bacteria but don't kill them. Also that it doesn't affect any other types of bacteria. That seems like it would be a fine line. How confident is Corteva that these products are not hurting microbial populations? Yeah, great question. And it is a question that we get a lot, especially as we have learned more in, I would say, more recent history around the importance of bacteria. And so this is an area that we have studied quite in depth and have done a lot of research around the rates of nitropyron, so our active ingredient, and how that affects bacteria. And so we do have studies, and I happy if we want to share some of those studies, but I am happy to share those that we have done research both internally as well as with third parties to understand how does nitropyron affect other bacteria, and at what rates do we start to change things? Because as you guys know, whether it's herbicides or stabilizers or Tylenol in your cabinet, your medicine cabinet at home, it is the rate that or the dosage that makes the poison. So for example, you can take a Tylenol and be totally fine. I would not want my 2-year-old to get into a whole bottle of Tylenol, right? That is where you start to get the poison. So a similar effect happens. Can you kill Nitrosomonas bacteria with Inserve or Instinct? Yes, you could. The rates that we look at is you have to be at about 100x rate in order to kill that bacteria. So again, we have done lots of studies. And so at the rates, our rate is at a per acre rate. That's another thing that's important to note. Because we are affecting the bacteria, we apply these products on a per acre basis. And so because we know that that rate is low enough that it is not killing the bacteria, it is simply starving them for that period of time. A very high confidence level of the kind of isolated impact that we're making with these products. Great question, Jean. Wondering if there's a significant difference between Corteva's stabilizers and other stabilizers on the market. Absolutely, yes. I mentioned that lots of different, it's interesting. I've been in agriculture going on 15 years now. And it's interesting just in that period of time, how many entrants we've had come into this space, right? There's a ton of great activity that's happening with understanding microbiomes and understanding the impact there. There's a lot of great work that's being done with biologicals and how those processes can impact the production of corn. I would say the double-edged sword to that is that there's a lot of companies that are putting products out on the market that maybe don't always do what they say they're going to do. They see it as a huge opportunity and a chance to make money. And so I would say there's a lot of confusion in the marketplace today when it comes to stabilizers, additives, some of these kind of micro enhancement type products. There's just a lot of confusion. And so if I'm a farmer and I'm looking at this, I would be quite concerned that I'm putting my money with something that is effective, that's proven, and that's going to deliver me that return on investment. And so to answer your question directly, yes, there's a major difference, and that is that active ingredient. So in Instinct and Inserve, you have nitropyron. Nitropyron has been around since 1976, so almost 50 years of being on the market, delivering these results that we're talking about here today. We are the only company on the market that can show you decades of research, thousands of trials, and delivering this type of consistent results. Other products have different active ingredients. Probably the most common one is a product called DCD. And DCD has been shown by university research to be a nitrification inhibitor. So they work similarly to the way that nitropyron works. The problem with DCD and what universities have come out to say, because DCD has also been around since about the 80s, so it's just a little bit younger than Nitropyron, but it does not have the same type of results. So it does not have the decades of showcasing this return on advantage. And the reason that universities would tell you, and from what we can tell, is that it's, again, all about the dosage that makes the poison. So the rate of DCD that you need to be effective is far greater than what we believe is probably going on in these products. The other thing that I'll say about DCD, which is kind of a cool fact, is that DCD is 67% urea. So DCD by nature, you're getting a little bit of additional nitrogen just by having that DCD in the tank. So you may ask, well, why wouldn't I just apply more nitrogen? And the problem comes down to this process right here that's happening. You can apply more nitrogen, right? You can add 20 more units of nitrogen, and you may see a crop response from that in a good way, right? You may see a favorable yield response, but this process is still happening. This nitrification process is still happening. And so you are still susceptible to loss from denitrification and leaching. It's just that you've got a bigger application of nitrogen out there that's now susceptible to loss. And so the example we give is, if any of you guys have cows or have worked around cattle, if you have a hole in your fence and you're losing cattle out of this hole in your fence, are you going to fix the fence, or are you going to throw more cattle out there into your pasture? You're probably going to fix the fence, right? You're not going to just add more cattle. You're going to fix the fence. And it's similar in this regard with nitrogen and stabilizers. Of it doesn't make a ton of sense to just add more and more nitrogen. It makes a lot more sense to fix the hole in your fence, in this case, to address that nitrification process that's happening. So I hope that answered your question, Jean. Different active ingredients, and what we see is different results at the end of the day.
That did. That was great. Thanks, Brittany. I guess I'm just kind of curious too, using your analogy about the cows, because I do hear from farmers, right, that just adding a few more pounds of nitrogen is good insurance, right? But thinking about, you wouldn't just throw more cows in a pasture where it's all leaving. I'm wondering though, just kind of maybe could we make it a half a step back to like the nitrogen cycle and kind of the overall processes? And is there anything within there that farmers can do as well, or consider from a nitrogen management standpoint, that maybe you haven't touched on, or you maybe a little bit more, maybe more details?
Yeah, so that's a good question. Well, I think one thing that farmers can do when thinking, and again, this is such an interesting space because every farmer utilizes their nitrogen program a little bit differently. One thing that you may consider, I mentioned that 70% of loss occurs below ground, 30% occurs above ground. One thing that a farmer could consider to take away that 30% loss that could be happening is to incorporate their nitrogen application. So obviously anhydrous ammonia is going to get knifed in, so you're not at risk of volatility there. And then with your urea or your UAN application, if you can incorporate it, or if you're going to get rainfall, planning those nitrogen applications within that can certainly help affect and making sure that you that your nitrogen gets into the ground and is not susceptible to loss. The other piece that that you could consider is thinking about your forms of nitrogen. So obviously urea, UAN, and anhydrous are comprised differently of ammonium and nitrate nitrogen. And so you are most susceptible with that UAN, with the 25% of it already being in that nitrate form of nitrogen. And then you've got, I'm sorry, did I say that correctly? You're most susceptible with UAN because 25% of it is already in that nitrate form, right? Urea, ammonium, and nitrate. So 25% already being negatively charged. And so right out of the gate, it is susceptible to loss. And so I guess, one thing to consider would be if you are a UAN user, I think it should be a no-brainer that you're utilizing a stabilizer because you already have 25% that you could be losing. And then this is that this is that kind of the role of crops and how that process happens. I didn't know if you had any questions, Jean, specifically on kind of this or anything in this space.
No, I think this is a good overview. I think it's more just, you know, context wise of recognizing that nitrogen is one of our biggest environmental concerns from agriculture, especially as it relates to like Mississippi River water, you know, and even it's not even Mississippi River and Gulf of Mexico. It's like a lot of local municipalities are drawing water for drinking water supplies. So just kind of thinking about other ways or more holistic systems approach concepts that we might take away from a better understanding of the nitrogen cycle that could help also kind of offset or minimize some of that environmental and health risk.
Sure, absolutely. Yeah, and I think, you know, the government is doing a lot with like EQIP dollars, and the Inflation Reduction Act is really pouring in funds into those programs with NRCS. So those are things like cover crops, you know, reduced till, obviously lots of different practices that can get you rewarded from a government standpoint to help push in that direction. And those are all great practices. I think my one comment that I would maybe think about with that is that from what I talk to with retailers and farmers is that not every farmer is either set up for or wants to do cover crops. My comment with stabilizers and specifically with Instinct and Inserve, because of those environmental benefits that we see, those tangible benefits, is that I believe every farmer can use a stabilizer when they're applying their nitrogen. It's a very easy step that they can do that really makes a very tangible impact in reducing that environmental load that we're putting on, like you said, obviously the Gulf of Mexico and the Mississippi, but down to your streams. There's a guy on my team who has just a creek that's running through, and they do a lot of trout fishing out of it. And he was like, look, Brittany, the Gulf of Mexico is great and all that, but like my kids fish out of this waterway. Like I want to do everything I can to make sure that I'm protecting it. And that's where I think it's getting this message to everyone within the agriculture community that we've got some very real solutions available to us that create a very powerful benefit in the long run. It's just making sure that we have awareness and access to those tools that is so critical. But yeah, there's multiple different ways that we can help. And it is a good thing, right? Whatever you want to say about the government, it's great that we have some funds that can help promote these types of opportunities for our farmers and for ag as a whole.
Yeah, Brittany, I think this has all been real good. And I guess to Jean's point, we do want to point out that this was kind of designed as the pre-work for the training next week. So next week will be all about how cover crops, soil health, those other practices are going to help keep the nitrates out of the soil. But, you know, today was really about getting that background in the nitrogen cycle, which, you know, understanding how these inhibitors work kind of, you know, you have to understand the nitrogen cycle, and it all kind of connects in a different way. So yeah, we will certainly address a lot of those things next week, Jean. I don't know if you're able to join us or not, but everybody, yeah, keep in mind, and to anybody who was looking at this as a recording, and maybe for some reason, if anybody in the future is watching this kind of set apart from the training, that this was kind of intended to fill a certain portion of the knowledge that we want everybody to gain from this training. So this is by no means an all-encompassing look at nitrogen or you know, soil health and how we keep nitrogen and nitrates out of our waters, lakes and streams. So this was just kind of getting that background for the nitrogen cycle, making sure that that was all getting addressed, which I think we've done an excellent job of, and then understanding, you know, as Brittany points out, a very simple, realistic thing that many farmers could do for that first step to reduce nitrates. So I think we do have about 2 minutes left. So if there's, you know, any other quick final questions other than that, I know Brittany, you may have some time, but we want to be wary of anybody who has to drop off at 2 o'clock. So we want to thank you for joining us. And if somebody has like a real quick final question, I don't think anything else dropped in the chat, but
nothing. Nope.
All right. Well, I think we probably better go ahead and wrap up. Brittany, if you want to stick around, that's fine. But I think we'll kind of go ahead and do an official kind of end the recording so we can end this at an hour and keep it at an hour-long recording. And if anybody has any final questions, you're free to stick around if Brittany has a few more minutes.
Yeah.
But thank you all for joining.
Glad we made it. Again, apologize for the delay. Glad we made it in under the time crunch. So thanks for hanging in there with me, and appreciate the opportunity. And yeah, happy to stick around if there's any other questions.